talk about naming ionic compounds. Compounds, when you put two things together, two elements, they have a specific ratio, they're bonded. You have water and salt, water H2O, salt sodium chloride, and you have the chemical formula NaCl for sodium chloride. The chemical formula of an ionic compound has the constituent elements, which means what it's made out of. Constituent means what it's made out of. And the ratio to combine. You have a monatomic ion. You change the name to IDE. That's all you do. So, chlorine becomes chloride. Oxygen becomes oxide. Some metals can form cations. A cation is a positive charge ion. It can have more than one charge. Iron 2 or the ferrous ion. These are your transition metals. These are the ones located between the alkali earth metals and it's the one in the middle of the periodic table. Then you have the ferric ion, which is iron 3. I don't know ferrous ion or ferric. No one ever says that. They'll say iron 2 or iron 3. It refers to these metals that form cations that have more than one possible charge. And you can normally sort it out by appearance, by gauging how many oxygen it has with them or what kind of molecule it forms. Magnesium is magnesium 2 if it's 2 plus. Manganese 3 if it's 3 plus. Manganese 4 if it's 4 plus. Here's all your different ions. Notice aluminum, barium, cadmium, calcium. You don't care about the part charges. It's not like aluminum 2. No. If it only has one charge, it exists in one form, that's the ion. When you see the Roman numerals like chromium 3, 3 I's, that means it refers to the charge, and that chromium has more than one state. Cobalt 2, copper 1, copper 2, iron 2, iron 3, lead 2. These are all the ions, and they have all different states. Anions are negative. Bromide, chloride, fluoride, hydride, hydrogen. Just take the element, take off the end of it, put IDE. Note, anions do not have like a 2 or 3. It's only the cations, the positive ions, and only the transition metals. So the formula, they're normally empirical formulas. An empirical formula is like the lowest common denominator. You're not going to have, you have H2O, but you're not going to have H4O2. You know, you go to the lowest common denominator, H2O. Okay, simplest form. And ionic compounds are electronically neutral because they combined the sodium atom and combines with the chloride atom. The sodium will lose an electron and be positive, so that's a cation. This is a weird thing. A cation loses an electron, which is negative, that's positive. An anion gains an electron, but is negative. So normally the charges balance out. That's how you know how many numbers there are in the formula. The sum of the charges on cation and ion must be 0. So you have aluminum oxide, which is Al3, but you have oxygen, which is 2 minus. So it's Al3, 3 times Al2, 2 aluminum atoms times 2. Each one has a charge of 3, is 6. And it's cancelled by 3 oxygens, which have a charge of minus 2. So minus 6. The sum of the charges must be 0 in the ionic compound. This table is very important. You should copy this down, print this out. Follow the flow chart. This compound contains a metal and non-metal. The compound is most likely ionic. Now, 2 parts you can veer. If the metal cation only has one possible charge, like the alkaline earth metals, the alkaline metals, Ag, aluminum, cadmium, zinc, then the naming will be named the metal first. Add the IED, and you get the root of the name. If the metal cation has more than one charge, do the same thing, but now you name the metal first, and then you specify a charge with the Roman numeral, and add IDE. So iron 2, oxygen has iron, and the II is 2, and then you add the oxygens in. Name the cation. Omit the word ion. Use a Roman numeral if the cation has more than one charge. Name the anion. Omit the word ion. So NaCN is sodium cyanide. Iron 2 chloride, because Cl is a -1. There's two of them, so you know iron has to be +2. We'll learn about how CN cyanide is a polyatomic ion later. Iron 3 has 3 chlorides because iron 3 has a +3 charge. Chlorine has a -1. There are polyatomic ions that consist of a combination of 2 or more atoms. There's an incredibly long list, but we'll keep it simple. We'll use these only. So they're same rule. Compounds contain only monoatomic ions. Ions combine in ratio to give a neutral formula. So calcium phosphate, PO4 3- is a polyatomic ion. And calcium is 2+, so you must put this parentheses. The little subscript 2 tells you have 2 polyatomic ions. Here are the common polyatomic ions that you're in charge of. Ammonium is NH4+, hydronium H3O plus mercury 1, and then you have these weird names on the anions. Acetate, C2H3O2, azide, which is N3, carbonate, CO3 2-. You got chlorate, chlorite. Note the 8s have more than the ites. Whenever you see 8, you always have one more O than the ites. So if I list chlorate as ClO3, chlorite ClO2. Dichromate refers to the front of it, so you have chromate CrO4 2-, but you also have dichromate, but that means you have 2 chromiums, dyes 2. Dihydrogen, you have 2 H's in front of your phosphate, etc. There are some other common polyatomics. You should know your sulfates and sulfites, phosphates and phosphites. PO4, PO3, SO4, SO3. How do we name the following ionic compounds? Do you identify cation and ion in each compound? Find the names for each. So Fe2SO43, iron 3 sulfate, because sulfate is a -2 ion in your table, and iron 3 is 2 of them, so it has to go 6. So that you know it's iron 3 sulfate. AlO3 is aluminum hydroxide. OH is hydroxide. There are 3 of them. Hg2O2 is mercury 1 oxide. Oxygens are always -2. Don't confuse the subscript in the formula with the charge in the metal ion. The subscript in iron is 2, but this is iron 3 in its part A. Then you have oxyanions. They're polyatomic ions that contain 1 or more oxygens and 1 atom. Oxyanions end in 8. We can name these ions as follows. This may or may not help you. Let's see if it does. The ion with 1 more O atom is always 8. Called the, so you have ClO3 is a chlorate, so ClO4 is a perchlorate. So if you have more, it's per than the 8. The ion with 1 less O atom than the 8 ion is called the ite, chlorite. The ion with 2 fewer O atoms than the 8 ions is called the hypo, so it's hypochlorite. So this is a way to remember perchlorite and hypochlorite, chlorate and chlorite. Chlorate is ClO3, chlorite is ClO2, perchlorate is ClO4, and hypo is ClO by itself. You should memorize your oxo ions that end in 8 so you can apply these guidelines when necessary. So this would be your sulfate, your phosphate, your chlorate. And here it is. Your nitrate, nitrite. All the 8s are above the ites. All the 8s are above the ites. Phosphate, phosphite, sulfate, sulfite. And if you know this, if you just forget, and you can't remember if it's ClO3, nitrate and chlorate are O3, phosphate and sulfate are O4. These are all the important ions you should remember that end in 8. chlorate, iodate, bromate, sulfate, phosphate, nitrate, carbonate, oxalate, chromate, and permanganate. And then you can remember your pers and your hypos along with it.